All right, so today we are talking about dilation, which remember is the one where things get bigger or smaller. It's the same shape, just bigger or smaller. So in our definition, we're going to put that a dilation is a transformation that alters the size of the geometric figure, but does not change its shape. So a dilation is going to show similarity. So remember, our other ones were showing congruency, which meant same size, same shape. This one is the same shape, but not the same size. So it's not congruent, but they are similar. Okay. All right. Then they give you two drawings here to show the two types of dilation there can be. We said it either gets bigger or it gets smaller. So one of these shows each of those. The first drawing says that in the figure, the measure of C to a point XY is twice the distance from C to a corresponding point on AB. So basically, CX is equal to 2 times CA, and CY, this line here, is equal to 2 times this portion here of CB. Okay. So in the transformation, AB with a center of C, so just like we had a center in what we were doing yesterday, we're going to have a center here as well, and that point is called the center of dilation. And since center C was our center of dilation and we had a scale factor of 2, this figure was enlarged by a scale factor of 2. Okay, so if K, or the number that you're enlarging or shrinking by, is bigger than 1, so if K is larger than 1, the dilation is an enlargement. Okay. All right, in this second figure over here, it says in the figure, the measure of C to some point on PQ right here is a third of the distance it is from C to some corresponding point on AB. So basically, CP is a third of the length of CA, CQ is a third of the length of CB. In this transformation, with a center at C, so again, C was the center of dilation, and a scale factor. Okay, on this one, our scale factor was 1/3, right? So if your K is between 0 and 1, then the dilation is a reduction, or it's getting smaller. So basically, a decimal or a fraction is going to show a reduction. Okay, so now that we have that information, they give us two examples where they want us to enlarge or reduce the figure. So here on example 1, part A, it says that we are given a center C and then a scale factor K. So on part A, our scale factor is 3/4. So is this thing going to be getting bigger or smaller? Smaller. So this one is going to show a reduction. Okay, well, if I want to show this figure being reduced by 3/4, that means whatever this side length is, I reduce it by 3/4, right? So this side right here is CX. Whenever I put some new point here, I would call it X prime, right? Because it's the same thing, just being made smaller. So to find that new line segment, CX prime, we just would multiply the original line CX by 3/4. So all we need is how long CX was. So we're going to take our ruler and we're going to measure in millimeters. So on the small side, how far it is from 0 to that point X, okay? So last period, there was some debate on whether it was at 35 or 36. It's somewhere in between. Yeah, make sure you're on the millimeter side, not the inches side. I think it's 36, but some of you may have gotten 35. This was the one segment that there was some debate on last period. So just so that we're all using the same number for notes, let's say it's 36, okay? So 3/4 times a measurement of, we said it's 36 millimeters, okay? So I'm just going to go ahead and multiply that. What is 3/4 times 36? Good. So our side CX prime is going to be 27 millimeters long. So I'm going to take my ruler here and I'm going to make a little mark between C and X at 27 millimeters. So right in there somewhere. Okay, so here's my point X prime. Okay, and then just like our examples had up at the top, I'm just going to draw a dotted line. Okay, all right, now we're going to have to do the same thing to find some point Y prime down here. So if we want to find CY prime, all we're going to do is multiply whatever the length of CY is by 3/4. So we take our ruler and we measure in millimeters how far it is from C to Y. 44? Yeah. So I'm going to put 44 millimeters here. And what is 3/4 times 44? So that means that the segment CY prime is 33 millimeters in length. Thank you. All right, so now I'm just going to take my ruler and make a little mark at 33 millimeters. All right, so I'll put a point there, and that is my Y prime. Again, I'm just going to draw the dotted line from C all the way to Y. All right, and then the very last thing we need to do is take our ruler as a straight edge and connect the points X prime and Y prime like they did in the examples above. Okay? All right, and then we will be asked to give some statement about this new figure. What kind of lines are X prime, Y prime, and XY? They run beside each other, parallel. That's going to be our statement. So the original line XY is parallel to X prime, Y prime. Okay. B is pretty much asking us to do the same thing, but this time our K is 3. So is that going to show a reduction or an enlargement? Okay. Okay. All right, so same idea. First thing we want to find is our CX prime. But in order to do that, we're just going to have to multiply the original line CX by 3, right? So we're going to have to take our ruler and measure how far it is from our center of dilation C to X. Some people are saying 16, some 15. Mine's looking like right there. Mine looks closer to 15 than it does to 16. We'll go with 15 so we're all using the same number. Okay, so really it's 3 times 15 millimeters. Okay, so what is 3 times 15? 45. So our CX prime is 45 millimeters long. So take your ruler and measure from your center of dilation. It needs to go through the point X. You're going to make a little mark where 45 millimeters would be. Okay? Yeah, start at your center of dilation C, and it needs to go through point X. Okay? All right, now we're going to do the exact same thing, but for Y. So to find CY prime, I'm going to just need to multiply the original segment by 3. Okay, how long does it look like CY is? 15 or 16, same length. Okay, we'll just use 15 again then if it's the same. So which would also make this one. Good. So I'm going to take my ruler and make a little mark at 45, and that's going to be my point for Y prime. Okay, so again, make sure you go back and draw those dotted lines between them. Okay, and then our last step is to take our ruler and use it as a straight edge to connect your X prime and your Y prime. Okay. Okay, and we could also make the same statement here, that the original line segment XY is parallel to our new line segment X prime Y prime. Okay? Everybody have those written down? Okay, flip it over onto the back. Okay, on these figures, they're asking you to come up with a scale factor on the coordinate grid. So you won't need your ruler, you'll just count the number of units in change on the coordinate grid, okay? All right, so whenever you are setting up your ratio to find the scale factor, your K is always going to be the new over the old, or the image over the pre-image. Means the same thing, right? Okay, so down here it says, determine the scale factor used for each dilation with a center C. The dilation image in the figure is shown with a dotted line. So the new figure is the dotted one, okay? All right, so first we're going to pick our point of dilation. Well, we can see that this one is kind of centered off this corner, right? It's closer into this corner. So we're going to make the corner of the dotted one our center of dilation. We'll call it point O. Okay, so to find K, we said we put the new over the old, right? So the new is the dotted one. So I'm just going to count how many units the side length of the dotted rectangle is. What did we say it was? 10. Okay. So 10 over. Now I'm going to count the old, or the pre-image. How many units is its side length? 5. Okay. All right, so now I just would simplify. What is 10 divided by 5? 2. Okay, so did this one enlarge or reduce? So this one shows an enlargement. Okay. All right, on B. These figures are right on top of each other, so they must have grown from some point in the middle and out. So I'm going to put my center of dilation right there in the very middle of the figure. We can call it 0.0 again. Okay. And I'm just trying to figure out how far it went from my center of dilation to that outer point. So how many units from the center is it? 2. So I got K equals 2 over, for the dotted one also. So the dotted line and the original are both 2, so it simplifies to 1. So did this one show any kind of dilation? No. So no, or not a dilation. Okay. On C. Okay, this one they gave you your point of dilation. They already drew it for you there. All right, and they said that we need to put the new over the original, okay? They said the new was the dotted, okay? So I'm going to count the diameter of my circle. How many units is it across that circle? 2 units. The diameter of this circle. Okay? All right, then I also need the diameter of the old to be able to compare them. So how far is it across the old circle? 5. Because it goes halfway and halfway on that last one, which would make 1 whole unit, right? So 4 units in the middle plus a half and a half. So 5. And can I simplify 2/5 any further? No. So did this one show enlargement or reduction? Good. Yes, you can see it's a reduction, but you have to give me the scale factor. All right. Number 3 here says to draw the image of MHS after a dilation with a center at 0, 0 and a scale factor of a half. Okay, so our center is right here at the origin. And I'm going to also go ahead and plot my pre-image points, or the original points. So I've got a point at 0, 4. I've got a point at -6, -2.
Teachers, pardon the interruption. At this time, the AC has been fixed in the gym. If you are a student who missed your appointment for the blood drive, you can go ahead and head that way, and we will continue on with the normal blood drive schedule from this point forward. Thank you.
Okay, so here are my points for M, H, and S. Now I just have to find their new points. Okay, so if I am wanting to reduce them by 1/2, just like on the front page, we just multiply whatever it currently is by that scale factor, right? Okay, so for M prime, for my new M, I have to multiply both of the coordinate points by what I'm wanting to reduce by. So that would be 1/2 times 0 and 1/2 times 4. Well, 1/2 times 0 is just 0. And 1/2 times 4 is, okay. So my M prime is at 0, 2. Okay. All right, I'm going to find H prime the same way. I'm going to multiply both of my coordinate points by 1/2. So 1/2 of -6 and 1/2 of -2. Well, what is 1/2 of -6? and half of negative 2. So H prime is at negative 3, negative 1. All right, and then same thing to find S prime. Half of each of the coordinate points. So half of negative 4 and half of 3. So what is half of negative 4? Good. And half of 3? 1.5. So I go plot this for my S prime. I'm at negative 2, 1.5. Okay. So I can go back and draw my dotted lines connecting these all the way from the original back to the origin. Okay. Yeah, you can't really see my one that's on the y-axis, but the other two I did draw in there. Okay. All right. Okay, in this last problem, it says find the resulting image of FROST after each transformation. Be sure that each transformation is dependent on the previous one. So you got to have your answer to A, and then you use that one for B, and so on. Okay. All right, so first I'm going to just go ahead and plot these original points. So we've got at 0, 2 is F, at negative 2, 0 is R, at negative 1, negative 2 is O, at 1, negative 2 is S, and at 2, 0 is T. Okay, so I'm going to go ahead and connect those points. All right, so there is my figure FROST. Okay, so on part A, it says we are going to reflect this over the line y equals 2. So that's kind of like the one on the homework assignment, right? Y equals 2 is a line that runs horizontally through the point 2. Okay, so it runs right here. If I reflect F and F is on the line, is it going to move any? No. So F's point is going to stay the same. Okay. All right, for R, currently, how many points below that line of reflection is R? So if I reflect it across, then that's going to end up how many above it? 2. And the same for T as well, right? Okay, so R was at 0, now it's at 4, and the X value didn't change. So negative 2, 4, and T is going to be at 2, 4. Okay, so here is my R prime and T prime. All right, and then we're going to do the exact same thing for O and S, right? How many points below that line of reflection is point O? 4. So when I reflect it up, it should also be 4 above. So there's my O prime and my S prime, yes, which would make it at 6. Okay, so my O was at negative 1, negative 2. Now it's at negative 1, 6. S was at 1, negative 2. Now it's at 1, 6. All right, now I'm going to go back that I've got those all plotted and connect them. And there is my second image, or my FROST prime. Okay, B says we're making these changes, but it's dependent on the one before. So now these are my original points, the ones from A. Okay, so I'm going to make these changes to these coordinates that we just wrote down. Okay, so minus 3, what direction does that mean I'm moving? Left 3, okay. So I was at 0. If I move left 3, I'm at, good. And then minus 2 means down 2. 2 minus 2 would put us at, good. So at negative 3, 0 is F double prime. Okay? Same thing for R. I'm looking at these points. What's negative 2 minus 3? negative 5. And what's 4 minus 2? 2. So our double prime is at negative 5, positive 2. Okay? Right here, what is negative 1 minus 3? Negative 4. And what is 6 minus 2? 4. So O double prime is at negative 4, 4. Okay? S was at 1, 6. 1 minus 3 would put us at negative 2. 6 minus 2 would put us at, so at negative 2, 4 is going to be S double prime. Okay, and then for T, 2 minus 3 and 4 minus 2. So at negative 1, positive 2 is T double prime. Okay, so let's connect those. Okay, so there's my image for all of our double prime coordinate points. All right. Okay, C. Now I'm using my coordinate points from B, right? These ones here. It says to rotate them 180 degrees. Well, when we rotate 180 degrees, what's the only thing that changes about our coordinate points? Right, we change their signs. Good. Okay, so if the coordinate point was negative 3, 0, it's now going to be 3, 0. Good. And if the point was negative 5, 2, it's now good. And negative 4, 4 will become negative 2, 4. Just change their signs, right? So just make the 4 negative and the 2 positive. And then for T, it'll become good. All right, so I've got a point at 3, 0 for F triple prime. I've got a point at 5, negative 2 for R triple prime. 4, negative 4. Oops, move that a little bit. Okay, 4, negative 4 for O triple prime. 2, negative 4 for S. And then 1, negative 2 for T. Okay, and then I'm just going to go and connect these points. Okay, and last one. Oh, gotta work quick. Okay, dilation of 2 for these points. That just means we do what to every coordinate point? Multiply it by 2. So 3 times 2 is 0 times 2 is just 5 times 2 is, and negative 2 times 2. 4 times 2 and negative 4 times 2. 2 times 2 and negative 4 times 2. Good. And then 1 times 2 and negative 2 times 2. Good. Then we just need to plot these points. So at 6, 0 is F quadruple prime. At 10, negative 4 is R quadruple prime. At 8, negative 8 is our O quadruple prime. At 4, negative 8 is our S quadruple prime. And at 2, negative 4 is our T quadruple prime. Okay, so when I connect those points, there we go. Okay.